Today's video, it's all about this house number I've made. Here's the pattern. It's made out of perspex. It's about 6mm thick. Here's the back side of it. Now what gave me the idea for this, I like the shield. It's a lovely shape. So I'm going to ask you, do you like the shape for a house number, a shield? Do you like it or hate it? Put it in the comments. So the material I'm going to use for this casting and for some of the others, and as they need only a couple of holes drilled, I'm going to use a disc brake rotor. Another casting I will be pouring today is this burglar alarm bell. But pouring it in cast iron is going to be tricky, very difficult. One, this casting, or the pattern I'm going to use, is 3.5mm in thickness. It's very thin compared to the number 14 sign, which is 6mm thick. And the second reason is it's being poured in cast iron, and when you pour castings so thin, they are bound to go white very hard, which is great for a bell, makes it sound really well, but I have to drill a hole in it. So we'll see how we go. Just like to say, today was one of those days where some things just don't go right. And the first thing was, I thought I had deleted enough videos, past videos on my camera, but I hadn't. And you know when you find that out is when I had the camera mounted to the pouring trolley and I switched the camera on and that dreaded message comes on, insufficient memory. So if you are looking forward to seeing cast iron pouring, I'm sad to say it won't happen on this video. This is the first time it's ever happened to me. And the second thing is, when I tried to pull the pattern from the mould, I didn't screw the withdrawal screw tight enough and it fell into the mould and destroyed the mould, so I had to make it again. Yep, it's one of those days. It actually works when you screw the screw down a lot harder than I did last time. As you saw in the last clip, it fell out. Now this was the first casting I poured. It's the house number, number 14. It's a fairly thin casting, 6mm thick. Now you wait until you have a look at the next casting. That's the bell from a burglar alarm. It's nearly half the thickness of that number 14 sign. That still filled up the mould. So I was very curious. I would pour that normally first, but I poured it second just to see how fluid the iron was, and it was very fluid. And here we've got another one, another 14. I thought I'd pour 2 of them. This is the third mould, still filled up the mould. Very fluid iron. And here we've got some leftover metal. I thought I'd make some spaces up. They're very handy to have. There's 2 of them there. And then I tipped the leftover in here. It's very useful to have billets to put in the lathe. Now I'll give you a bit of a demonstration of what coal dust does to the sand when you're casting iron. Now this is just an ordinary toothbrush. Now watch this. Look how easy that sand just comes off. Just so easy. Now if you don't use coal dust, it can take a little bit of more wire brushing, but coal dust, when it burns, it lifts up the metal and it gives a very good finish, and the sand breaks down really easy. It just works so well. I'm going to show you an interesting discovery. You can see how the sprue, the iron, leaked out a little bit. Now it's amazing that it did leak out because I used clamps on this cheap chipboard and it was very tight. There's a very small gap, but it flowed. But what the most interesting part is, the wood burnt really badly, but you'll have a look. It's really smooth on that side, and this side it's fairly rough because of the sand finish on there. So what happens is, the wood actually burns, as you see. And remember when I poured it, there was all flames coming out. And what that does, it gets rid of the oxygen around where the iron is. It gives a very smooth finish. And normally the top of the sprue like that is very rough. And I'll show you another example. Now this is the other example that I was talking about. You'll see right down there where the wood's burnt, and it's given a very shiny surface, and see where it's spilt and it's run over the edge here. Well, what happens, this part here, because it's exposed to the air, it has a rough surface, an oxidized surface on it. And what I'll do a close-up and I'll show you just how different it is. This is the close-up that I was talking about, and you'll see on your left hand side there the molten iron ran across the sand, and the upper surface, which is exposed to the air, it's all rough and pitted. That's because the oxygen burns the iron. But what happened is, after that iron ran across the sand, it went onto the piece of wood underneath the mould, and the wood burnt and it gave a very shiny finish. What I'm saying is, if you cannot get coal dust, it might be an idea to mix sawdust with your sand, and you might be able to get a really good finish with it. Because I've had a few people complain to me lately saying that they can't get coal dust. So if you can't get coal dust, it may be that a good substitute is sawdust, because it does exactly the same thing. Sawdust burns like coal dust, takes the oxygen out of the mould, lifts up the metal and gives a very good finish. This is the wedge test from today's melt. Did you count how many times I had to hit that wedge test with the hammer? It took 8 hard blows to break it. That is very strong cast iron. And the main thing I'm looking for, yep, it's grey all the way through. That's all I want. So it's machinable. So this is the wedge test from this test. Now this wedge test is good for certain castings. Now if they're 6mm thick or thicker, it's okay. This wedge test will tell you all you'll need to know. So that covers about 99% of my castings, but for 1% it is totally useless, this wedge test. Now this ingate and runner, now you'll have a look, you'll see just there it's starting to get white and grey cast iron mixed together, and the very tip is white. And I'll show you why this wedge test is no good for those 1% of those castings, like that burglar alarm bell. I'll drill some holes in it and we'll see how hard it is. You notice the other side, it's grey all the way through. So this shows you a little bit more, but I'll give you an idea with what you've got and how you can tell what sort of cast iron you've got. This is the burglar alarm bell. Now this is what I call a troublesome 1% casting. I need to drill a hole just in there. Now I'm very confident that hole will drill because it's the centre part and it cools the slowest, so it'll be grey. But you see all this flashing here where the sand broke away. We'll give it a file and we'll see what happens. Woohoo! Yeah, that is really hard. That is hard as well. The only way you can clean that up really, you can't use a file, you'll have to use a grinder, which is no problem. Now what I'll do, I'll drill a hole in there and then I'll try and drill a hole right on the very edge and see if I can get through and see how far back it's very hard. So I put the bell in the lathe, and I've got to say I had a bit of trouble using a centre drill to put that pilot hole in there. Anyway, it's amazing how the 1% of your castings can give you 99% of the trouble with cast iron. So we'll drill a hole in it and we'll see what happens. Well, that wasn't too bad. It might have been because it was flexing it so thin in there. But interesting. This is cast iron. Have a look at the chips there. I don't know whether you can see that or not. They're almost like steel. Now have a look at that chip. You'd think it was steel, but it's not. It's cast iron. Breaks quite easily. This is the final test for the burglar alarm bell. Did you see how hard that flashing was? I had to use the grinder because the file wouldn't touch it. So I reckon I'm really pushing my luck if I can drill a hole through it. But we'll see what happens. Well, amazing things do happen. That'll show you that the cast iron, probably close to the edge, you can still drill it, but the flashing is very thin. That thickness there is 3.5mm, but the flashing is really thin, probably less than 0.5 millimetre, so that definitely is chilled. But that part there, it drilled through quite nicely, which was a surprise to me. After the drill test on the burglar alarm bell, I would assume that it's mostly grey cast iron. Now I would like it to be white cast iron, it'd give a better ring, but the proof is in the pudding. We'll see what it sounds like. Yeah, I can still hear it ringing. That's pretty good for cast iron. Here we are at the end of the video, and I finished the plaque, painting it. So I'll give you an idea of the size. This is a 300mm ruler, so we've got 215 wide and 275 high. And I'm really pleased with the plaque. It come out really nice. It just shows you if you use something useless like a scrap disc brake rotor, you can make something useful like a house number.